When the CSN, or also known as SS pin, is pulled to the low position, the chip is selected. CSN means chip select not. SS means slave select. MOSI means master out slave in, and this pin transfers data to the target chip. MISO means master in slave out, and this pin receives data from the target chip. There are 4 SPI modes, and the SCK pin works with different signal peaks according to these 4 modes. These modes determine polarity and phase. Polarity determines whether the signal will be high or low in the initial state, while phase determines whether data will be sampled on the first or second edge. Sampling means reading bits of data at a specific moment in time. For example, in the zeroth mode, when the polarity is at 0, that is, at the starting position, the signal is low. Again, in the zeroth mode, the phase is also 0. In other words, when the SCK is low, data will be sent over the MOSI pin and will be sampled on the first rising edge of the SCK pin. That is, on the first edge. This means the data will be sampled on the rising edge. When we look at mode 3, we see the polarity as 1 again. We see phase as 1 too. This means that initially SCK is high. That is, the polarity is 1 first of all. SCK will be pulled to low position and data will be sent via the MOSI pin. And when the SCK is pulled to high position, the data will be sampled. So, the data will be sampled on the second edge of the SCK. That is, the second edge of the clock signal. In this example, LSB and MSB describe how to send 1 byte bit by bit. MSB indicates that the most significant bit, that is the leftmost bit, will be sent first, and LSB indicates that the least significant bit, that is the rightmost bit, will be sent first. The sending process then continues either from left to right or from right to left. I will not mention the abbreviations again because I have written them in parentheses. The high and low points corresponding to the white lines represent the base of data sent over MOSI. Here we see 2 types of connections, direct connection and chained connection. In direct connection, chips can be selected one by one and processed separately. Selection is made with the SS pin. The master can perform the chip selection process as it wishes. In chain link, all chips are selected at the same time and they process the sent data if it belongs to them or they work as defined. As the number of chips in the chain link increases, the communication speed with the remaining chips at the end of the chain will decrease inversely. Since the data entering from MOSI comes out of MISO in an echo-like manner, the MISO pin of the first slave chip is connected to the MOSI pin of the next chip in the chain connection. But the data coming out via MISO may not always be the same as the data entering through MOSI. For example, during read operations different data might be returned or some operations may result in predefined outputs. This depends on the operating conditions specified in the datasheet of the chips. Reading is usually done with 8 bits of data, which could be all ones or all zeros depending on the transmitted information. SPI is a full duplex communication protocol. This means that data transmission and reception can occur simultaneously, that is, bidirectionally. In SPI, both the master and the slave can send and receive data at the same time. This is a feature that increases communication speed and ensures efficiency. Here we see the polarity and phase information of SPI modes. We see information 0 about N pin. The tasks performed by the N are defined in the chip datasheet. N can perform different functions. N can be defined with different names like other SPI pins. N is not part of the SPI standard. N may not be present on all chips. Here we have one master and one slave chip. Chip X is the master and chip Y is the slave chip. We see that the configuration register is hexadecimal 01. First we need to access this address. We will access this address by sending 1 byte. Then we will write 1 byte of data to this address. When we write hexadecimal 01 to this address again, we see that the pin named A1 will be pulled high. N pin will allow the transactions to take place for the two chips in this example. Once the write operation is complete, A1 will be high once N pin is activated. Transactions will be carried out via mode 0. All connections have been made and named. Since this chip works as LSB, we will do the sending process from right to left. That is, we will send the first rightmost bit, B0. The first bit was sent over MOSI and we saw its echo on MISO. When SCK is pulled high, the first bit will be sent, and by repeating this 7 more times we will send 8 bits, that is 1 byte. The first bit has now been sent. Since the remaining 7 bits will already be sent as 0, we will complete the process by just polling SCK high and low. We have now accessed the configuration register. Now we will write 1 byte of data to this register. From the given information, we know that when B0, that is, the first bit is made 1, the A1 pin will be high. Again we send byte hexadecimal 01. When we activate the N pin, A1 is pulled high. Now we can pull the N pin low and unselect the chip. CSN is now high and chip is not selected.